Hi everyone, welcome. We're going to get started in just 1 second. All right, I'm going to go ahead and admit everyone to the Zoom call.
I will sign between. I'll transfer it.
Hi, good morning everyone. We'll get started in just 1 second. Going to let a few more people in.
I'm gonna write things down.
All right, good morning everyone. My name is Kevin Maselli. I'm one of the founding members of Invigilator Solutions. We are a student company that is being formed through the University of Central Florida through their capstone course and their Entrepreneurship for Defense courses. We have a government sponsor from Southcom as well as heavy support from the Defense Innovation Unit, and want to thank them for all their help. They've been paramount to our accomplishments and development of this product and business. Currently, there is a large lack in surveillance for maritime environments. This allows drug smugglers, human trafficking, and is overall a large breach in national security. Current solutions to this are very expensive, including aerial approaches. They're non-scalable, and the equipment that is sold to the government is very expensive and burdens them with ownership, maintenance, operation, and many other factors that go into owning the actual product. The solution that we're developing is the Maritime Domain Awareness System, or MDAS for short. This is an array of radar sending units. They're self-sufficient. They're going to exist on commercial vessels, local condo buildings, and buildings on the coastline, such as the one that we're on right now, as well as fixed structures on the ocean, such as oil rigs, cell towers, and any other place that we can mount these. And what it's going to do is it's going to enable us to have an array of overarching radar data for open ocean and coastlines. We're going to be components off the shelf, allowing for us to have a readily scalable system, and we're going to be only selling our data. We're going to be using a subscription-based data per hour, where Invigilator Solutions is going to own, operate, and maintain all of it. And we're going to be only offering a solution to our beneficiaries. We're going to offer them an interface where they can see all of this radar data in one location and take all of the burden of ownership onto ourselves. There's a range of applications for this, including drug smuggling, human trafficking, search and rescue, SOS operations, including national security, maritime traffic monitoring, and any other system that requires historic data. We can offer trends on maritime traffic on any given day if they're in our ranges, and as well as we've explored these for counter UAS as well, using this application for radar and having these self-sufficient radar nodes deployed. I'm going to go ahead and share my screen to show you exactly what we're looking at over here on the condo building. Right now we're in Stinger Island, and we have our radar set up on top of a condo building, as you can see behind me. Go ahead and share this. All right, so on the left here, you can see our MDAS software. We are on Palm Beach, so on the right here we have the marine traffic pulled up as well, and we're going to go ahead and be pulling some vessels that we see off the coastline. We're starting right now at 1.25 nautical miles. Hi, for everyone joining. Right now we're on the roof of a condo building in Singer Island. We are pulling up our software, which is the screen should be shared. If you can see on the left here is our radar that we're pulling live, and on the right is our marine traffic. And we're going to be pulling vessels as they come by. I think we can see.
.3 nautical miles is closest target crossing.
Point three.
You can see him heading north.
Point three. Yeah, as you can see here, passing over the mouse here on the right, past this dotted line, is one of the vessels that we're seeing passing right in front of us at the condo building. Do you want to put the camera over the ledge and look over? Yeah, thank you, Trevor. I'm going to go ahead and pull up the YouTube as well. It should be loading. There is a little bit of a delay, but it should go to the side in a second.
Secondary target heads south at .76 nautical miles.
That's this guy right here. So this guy's 0.6. This guy right here is 0.6, yep. You can,
Yeah, as you can see on the right here, Trevor is recording that boat passing by. We found an additional vessel, 1.6 miles due right.
on the marine tracker.
Yeah, so you can pull this up on the marine.
Click on it.
Actual targets.
Ready to move to 2.5?
All right,
Move to 5.
moving to 5.
Yep, moving to 5.
All right, for everyone just joining, right now we're on the roof of that condo building in Stinger Island. We're overlooking about 200 feet up. As you can see on the left here, this is our MDAS display. This is what's pulling the live radar data and displaying it over the map. On the right is our camera footage live picking up these vessels driving in front of us. And the goal here is to eventually have a system of these set up. We're going to have them all along the coastline and fixed structures to create an overarching array of radar data that can be utilized from one common source. And we're going to be selling this online as data, and we're going to be owning all these systems, taking all the maintenance and overhead, and taking the burden of ownership of the product and simply offering a subscription-based service to our beneficiaries. All is connected through Starlink. So everything is through satellite. It is going to be self-sufficient. These are going to be, we're going to drop them on, condo roof buildings, fixed structures. They're going to be minimally invasive. Right now we are honing into 2.5 nautical miles. And we're going to be able to pull some more up. I'm going to switch back to the marine tracker as well. We're also running that live YouTube channel. There's a link on the website. So if you'd like to follow along directly, that is the video of exactly what we're looking at on the rooftop. As well as if anyone has any questions, please feel free to enter them right into the chat. We'll answer them as they come in.
very small targets there.
So as we go out, the targets will look smaller based on
Distance.
mileage and distance.
So as we go up, things will be smaller.
So 5 nautical miles, we have targets at 20 nautical miles. We have a target at 5.31 miles, and it's going to be the target off to the far
This guy.
right.
So this guy's 5.3 nautical miles away.
So as you can see here on the left, we're picking up a vessel between the second and third band, about 5.3 nautical miles away.
You can hover over it. We think it's probably this guy. There's somewhere sunny.
It's already on.
Click on them and see what they're doing. Is there AIS? It's a yacht.
Yep. So we're picking up this guy right here, Second Love, as you can see on the AIS screen, and this correlates directly onto what we're picking up as well. So how this can be used is this can be used to track these vessels as well as identify ones that are not. We're seeing several vessels as well that are closer.
Tracking over 40 targets currently.
Alright, so we've gotten it to 10 now.
Okay, right now we are scaling up to 10 miles.
Show us if we know which one's left. This.
As you can see on the top right, we're also able to pick up weather patterns. That's that being displayed on the top right.
So we're currently changing all of our settings and everything, cleaning up a little bit.
Anybody else would need to get in? Same targets out
Drove the track some. So then we can integrate with it. Got a question about the PBX system. So it looks like it's just a refill of data.
Started answering some questions.
So the PBS subsystem, it looks like it's something that they utilize, various other systems for dispatch. So it could be something that we'd integrate with or further.
Yeah, absolutely. So,
Read the question. Answer.
so Michael's question, saying that this system is similar to the PBSO one we are already using. Is the same thing? So right now, what we're trying to do is create a large overarching network of radar systems. So that is something that we could integrate to, and what we want to offer is a service basis where it's going to be affordable to organizations, whether it's sheriff's departments, government entities, and offer them one location for all of this radar repository. If you'd like, I'm going to put our email into the chat. If you'd like, we can meet and dive further into that one, get the actual scope further. All good. Yeah, that sounds great, Michael. Thank you.
And further, other counties may not have that system as well. So, ideally, if we can put these on the coast, we can track something going through that, PBSO system and keep going north or south. Just follow them further up the coast.
It exceeds the range of their system, but it makes it a multi-jurisdictional system to where you can gather data, multi-jurisdictional data for tracks, for case history, for whatnot.
Absolutely.
Make sure you say that.
Yeah, so additionally, so with our system, it's going to be crossing jurisdictions and be able to be utilized by multiple organizations and be able to tap into this data. And we can see historic data of them, the vessels traveling through each jurisdiction zone. Yep. As well as reiterating that we will be the ones that own and operate this system, so we'll simply be offering that radar system, being able to see that radar data from anyone along the coastline. Does the system have a live recording? And can you... So does the system have live recording? Can you rewind footage to see vessels track? Absolutely. So that's what we're going to be integrating, is we want to be able to offer that historic data where we have years of background radar data that we can utilize to develop cases, to understand drug trafficking patterns, as well as other applications where we need to see that historic data. So we're absolutely looking to incorporate that. As well as search and rescue operations, seeing current data trends as well.
Bump out.
About 20.
So right now we're going to be scaling out to 20 nautical miles. So a question from Paul is, does the software have the ability to hook a track in order to monitor that track and provide course, speed, and projected path? So absolutely, we're looking to integrate that ability. We're going to be able to see if selected vessels, right? Especially if
a question from
it's a
Paul
zone where
is,
you're not expecting any traffic.
does the software have the
a lot
ability
easier
to hook
identify
a track in order to
and we're
monitor
trying to
that
provide
track
that
and
information
provide
with
course,
speed,
speed,
heading,
and projected
where it's coming
So
from.
absolutely, we're looking to
perspectively
integrate
where it's going to.
that
ability. We're going to be able to see. If selected, as well as it's also built into the radar, right?
So that's
Especially if
a
you just
question
transfer
for
it's a zone
Paul
where
is,
you're not expecting any traffic.
does the software have
a
the
lot
ability
easier
to hook
identify
a track in order to
and we're
monitor
trying to
that
provide
track?
that actively right now. We're tracking 40 targets where it's coming
So
from.
absolutely, we're looking to
perspectively
integrate
where it's going
that
ability. We're going to be able to see. If selected, as well as it's also built into the radar, right?
So that's
Especially if you
a
just
question
transfer
for
it's a zone
Paul
where
is,
you're not expecting any traffic.
Does the software have
a
the
lot
ability
easier
to
to
hook
identify
a track in order to
and we're
monitor
trying to
that
provide
track?
that actively right now. We're tracking 40 targets where it's coming
So
from.
absolutely, we're looking to
Perspectively
integrate
where it's going that ability. We're going to be able to see, selected, as well as it's also built into the radar, right?
So that's
Especially
right now we're
it's a zone where you're not
so about
traffic.
does the software have the ability?
So we can see about the 20 miles and track those vessels. As we go farther to that, we can still see them, but we do lose a little bit of the tracking ability.
21 miles.
See tank for 21 miles.
So right now we're monitoring 40 live. Tony, do you know how many we could scale up to? Do you know what the maximum is? 50?
Up to 50 currently.
We can do up to 50 on our current radar model. Which another benefit of us owning and maintaining these is as technology advances, we're going to be upgrading our units as well. So as there's new radars get implemented onto the market, they have better ability, something we want to integrate, we're going to be actively developing those models.
They don't have to maintain, they don't have to sustain.
Mm.
Plus that is you guys see the cost of the technology and the consumer does.
Mhm. Yeah, building on that as well, our company is going to take that overhead, and as the technology develops and advances, we're going to be the ones installing those systems, monitoring it, taking upon the burden of maintenance and overhead, removing all of that from our beneficiary, only offering that data service.
This is the tracker. 21 nautical miles. It's at 11 knots currently. That of course is 349. Yeah, well, I have the tracking, but you can see it down there. It's just hard to see as far as, yeah.
So they're actually the target right here. We're able to track him pretty well. He's about 21 nautical miles out. And that's a tanker.
Is that
Looks
better?
good.
Okay.
Yep. So it's a it's on 21 nautical miles out.
So that hard target right there.
Yep.
So
So it's on 21 nautical miles out.
correct all this, they got everything as far as they don't have it. So that hard target for there, the settings.
Yep. Yes. Yep. Yes. So read it, everything. So
Hi, Paul. So can the systems integrate AIS inputs to correlate with the radar tracks? Absolutely. So that's what we're working on, is eventually having this be all in one system where we're going to be able to incorporate those AIS inputs.
We're currently utilizing it as we speak.
we're doing it right now locally.
Mhm. Yeah, we're doing that locally ourselves, but it's eventually going to be integrated.
And they won't
So
have
it's-
to worry about it. It'll be all automated for them.
Mhm. Yeah, so this is going to be absolute. So, Doric, same kind of thing. So, is this radar system software able to show which vessels have active transponders? Absolutely. So that's what we're looking at now. We'll pull up an example on the left here.
Or that's storm cloud.
Right beneath band 2 as well.
Yep. So we have multiple. This blue heron is right south of that storm cloud. And there's another Top Gun is right here.
Yeah, Top Gun's so this guy out here, the boat beneath band 2 is a tanker.
Mhm.
The overseas. So I'm skeleton.
And I currently have on my screen, I have Second Love, this blue heron, Top Gun.
We're also able to see the second love still. This is the yacht
Special K.
down here. Again on the AAS, we're able to totally make a very clear picture of them and track them.
So we're looking at a radar view of those boats coming together offshore. That's specific targets that we're looking at that anomaly when it comes to offshore. So for trafficking, as far as you don't normally see two vessels come together. So we're looking at tracks where these vessels are coming together offshore, then entering inside these inlets and whatnot.
Mhm. Yeah, absolutely. So with this system, we're also going to be looking into historic data would be able to see different data trends, like for example, if two vessels they come and meet, and then they spend X amount of time, and then go into the inlet, certain characteristics like that to be able to identify them further.
Potential threats, human trafficking. and stuff.
Exactly, for potential threats, including human smuggling, drug trafficking, including if there's any
Anomalies.
any anomalies. Yes, thank you.
And from a search and rescue standpoint, the historical data, let's say we do have a track on something that is offshore that has an AIS and then goes to a mayday and loses power, we can look at the historical data to be able to put that out to multi-agencies so they can actually actively set up a track of the last known location based on historical data to improve search and rescue.
That's an excellent point. So to reiterate, for like a search and rescue operation, we'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that AIS signal, and or target. That's an excellent point. So to reiterate, conduct search and rescue, like a search and rescue operation, we'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that AIS signal, and or target. That's an excellent point. So to reiterate, conduct search and rescue, like a search and rescue operation, we'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels across agencies. So we can follow the pattern of that vessel, identify where we lost that location. We'd be able to use that historic data to track the last known location of vessels.
Yeah,
across,
so I'm going to read. So another question.
we can follow the
In what format
pattern
is
of that
the
vessel,
data saved? To what
identify
extent
where we
is the
lost
time
that
synchronization between
location.
different radars
We'd be able to use that historic data
time
to
to
track the
data?
last known location of vessels.
Yeah, so I'm
across,
going to read. So another question.
we can follow the
In what format
pattern
is
of that
the
vessel,
data saved? To what
identify
extent
where we
is the
lost
time
that
synchronization between
location.
different radars
We'd be able to use that historic data
time
to
to
track the
data?
last known location of vessels.
Yeah, so I'm
across,
going to read. So another question.
we can follow the
So in what format?
pattern
Currently,
of that vessel,
everything's
identify
accumulated
where
into
we
a
lost
secured server.
that
Radar
we'd be able to use that historic data
time
to
to
track the last
data.
known location of vessels.
Yeah, so I'm
across,
going to read. So another question. We're currently
follow
working on
the-
that
in
right
what
now.
format
So
is
currently,
that vessel,
everything's
identify
accumulated into
where we
a
lost
secured server.
that we'd be able to use that historic data to track the
Yeah,
last
absolutely.
known
So, but all that historic
yeah,
data
so
would all be
so
saved
another question
from
from the independent nodes themselves.
And then the active data would be overlaid as a wide net, so it would basically create an invisible field from every.
Yeah, exactly. So, and eventually with those server nodes are also going to be able to be utilized live. This map on the left here, if you can imagine, would have multiple nodes up the coastline. You'd be able to see all of that over encompassing radar data. So a question from Dorix. Once a vessel is identified that you want to keep track of, can you mark the vessel so it is not lost and remains traceable? Absolutely. So that's built into the radar system right now, and as well as we're going to be transferring it onto our site to be able to have that historic data and tracking them. We're going to be able to track that vessel between nodes as well and track it if it's going up the coastline and have all that data as well, where it's coming from, where it's going to, as long as it's in range of our radar nodes.
So essentially, it would leapfrog between radars up until we get to the point where it can be intercepted or surveilled based on where it's at location.
Yeah, absolutely. So we would be tracking it through each of our radar ranges to be able to offer that that data of the position, where it's heading to, where it's most likely going to be ending up.
And also setting it off, whether it be, you know, you can see it do in the daytime.
Mm.
And the pro of having this over on a vessel, as far as using it for interdiction, is the height. Being able to track this, so what would maybe out of a vessel range based on sea level, we now have height that's going into play that actually actively tracks targets more efficiently, so they can utilize that track on their vessel with their current radar setup on the vessel if it's an interdiction vessel or something like that. So height equals better range and better distinction between species.
And building on the advantage of being at the condo location is, like we discussed, is we're going to have that extended range and be able to utilize that larger radar distance and usable data to complete the operations.
So we're tracking small vessels.
Next question, it really shouldn't fade at all. 20 knots out.
Obviously, we're limited on the boost curve as far as that, but the height actually, based on where the radar's set up, it's actually giving you a better distinct pattern. And it's to that point right there is we're higher up, so we can see more of our nets, a wider casting net versus being on sea level if you're trying to track it with, let's say, one of the light crew boats or something like that. This also allows for multi-jurisdictional as far as operations where they may not have the same access as Palm Beach County Sheriff's Office. If DEA is involved, if Coast Guard's involved, now they can log onto one system where everyone can see everything off of one system, where it's just a login-based system versus having infrastructure that they have to pay for to put on their vessels in order to talk with everyone. So it doesn't matter if they have a 21-foot boat or a 35-foot vessel, everyone has access to it.
Paul, your question. So with the first track you showed us on the camera, the 30-foot sports fisher, about how far out does a track like that fade from radar at the height you're at? So we're about 200 feet right now. I believe it was good to 20 miles. We could track clearly up to 20 miles and have those trails. And from there, we're at this height, we're limited more of the curvature of the Earth than our tracking ability.
We go higher, we can see.
Yeah, absolutely. And as we go into higher condo buildings, we're going to be able to see farther.
And we did track a target today at 53 nautical miles.
Mhm.
An active track at 53 miles.
Yeah, and we also actively tracked a vessel at 53 miles a little bit ago, earlier today.
It's going to depend on, just like every other radar, sea state, weather, and local issues that you come into as far as that. But all of this is based on the same as any other radar in the world. Weather, precipitation, and whatnot. It's going to clean the track. If it's a clear day, we're going to see farther. If it's a nasty day, we're going to see less. I have a hard target at that going through that storm right there, and we're currently at 39 nautical miles. It's at a speed of 9.94 knots at a course of 103 currently. So we are able to pick up vessels within storms and whatnot. It's not currently showing here within that, but within that storm, we are actively tracking a vessel within that storm line down here.
Additionally, what you're seeing right here, this blob of red, so that's a storm, but we're actually able to track a vessel within that. It's not showing on this left screen, but on the radar data we're actually seeing, we're tracking a vessel through it with AIS.
No, not with AIS.
Excuse me, not with AIS.
That's actually
Additionally, what you're seeing right here, this blob of red, so that's a storm, but we're actually able to track a vessel within that. It's not showing on this left screen, but on the radar data we're actually seeing, we're tracking a vessel through it with AIS.
no.
So for anyone joining, we're currently honing in on vessels that are off the coastline of Stinger Island, Florida. Right now on the left here we have our MDAS software, which is picking up live radar data right behind me. And on the right, this is our AIS website that we're utilizing to identify these targets as well. That'll eventually be integrated. If anyone has any questions, please feel free to type in the chat. We'll answer them as they come in.
This guy's at 20 miles now.
There we go. It just has a bit of a lag.
But this guy's like 20 nautical miles out.
And we do
I
have
hear it?
Yep.
Yes, it,
within that, we have in that front right there, there's 2 targets, 39 nautical miles at a speed of 17 knots. Yeah, but, yeah, I mean, that's, you can, they're gonna come out of that. in a second.
Yep, so this guy's 20.
this guy's 20?
Yep.
Yeah, so we're also picking up, as you can see on this, on the left screen, a little bit south of where we're at, we're picking up a vessel 29 miles away. Did you know if that one has AIS?
No AS on that one. There are 2 targets in that.
Yeah, so that dot right now is actually 2 targets, and neither of them have AIS. This is a great example of how we could use this system to bridge that gap, right? And identify those vehicles that don't have transponders and filter them out, document their historic data, where they're going to, where they've been.
And we have a barge vessel at 47 nautical miles.
That's what this guy is.
47.
That's what that big book to the mid like straight right there. Might need to refresh too.
Yeah, I think I need to refresh.
It's on the
So
outside.
I have you log in.
Second
Is what page?
You can log back in. Good.
I might. I got it.
Good.
Cool.
Yep, so this guy.
Oh yeah, right there.
Yep.
What was the distance?
40,
40,
47.
47 knots, very large vessel.
46.6 nautical miles currently.
Oh, so this dot right here is another vessel we're picking up at 46 nautical miles.
It's just a large tanker.
That's just a large tanker.
There's smaller targets that are popping up around 50, which are these smaller vessels.
Those are probably ships transiting Freeport to Freeport, Bahamas.
So these are most likely vessels leaving Freeport, Bahamas. Right now we're seeing several vessels at around 50 miles away as well.
And we're tracking the usage. We're gonna bump out to 45.
Sure.
We're at 45 nautical miles. Is that right? Right now we're expanding to 45 nautical miles.
So it's just a slight shift in what we're seeing.
So we're at 45 nautical miles right now. You can still see the tanker moved in a little bit.
It's going to be around the Bahamas. Take your screen.
You guys probably zoom out a little bit. Simplify, yeah. That's probably one of the big red guys. That's it.
See the targets as we cleaned it up. The targets are showing.
Yeah, this guy is still there. That was
Which are larger targets.
So we've cleaned up the radar data a little bit. As you can see, these dots that are still showing are larger targets that we've identified.
As we decrease the image, then we have to disseminate as you go farther. For smaller targets, you have to disseminate in C state versus actual targets, which is something that you're integrating eventually where you can do automatically.
It's like basically C state. When there's a C state, it's a large target. We have to move factor out.
Make sure you're hearing your conversation.
Yep, so I can slide this closer.
So target right here picked up hard target 37 nautical miles. It's at 12 knots currently.
36
So that's what there's a guy in the clouds in the storm that was about 37 nautical miles out, and we're able to pick him up.
So the red, and explain that, the red is going to be a hard target where it's acquired a hard target. We know those are active targets that we're tracking.
So he just when we see a red, that's a hard target, and anything else is more so clutter and C state.
The lighter the color, the less active the target is. Green and red are what we're looking for. Oh, well, I guess I'm not sure. But the red is going to be an active hard target that we can track within that.
Yeah, so just to reiterate, what we're looking at right now is these red dots are the images that are subtracted, so that as we go farther out, we have to pick up the larger targets.
I mean, they'll be a lot more visible.
You can see our settings as we back out. Some of the settings we're going to start to see the smaller targets pop up.
Yeah, so right now we're adjusting, so you're going to be able to see some of the smaller targets appear as we adjust the settings.
We exit off that save.
Sorry?
We can exit out. Good. We haven't found the forms on
See
the
on the
website.
inside.
So,
So on our AAS side, we have 1, 2, 3, 4. We have Special K, Top Gun, Miss Blue Heron, Second Love.
He's just naming off some of the AIS vessels around us.
So they can see.
So we're able to pick up around 10 vessels that, on AIS, close by.
That are transmitting AAS basically.
And so those guys are transmitting AIS, so again, those guys, we wouldn't deem those as any, importance for us, unless they do some sort of, odd maneuvering or anything like that.
So we're going to go out to 72 nautical miles now.
We're going to bump it up to 72. Yeah, and keep in mind, this is now long range, so we are, beyond the curvature of the Earth as far as, our radar's able to pick up whenever you dream.
But we're seeing a target at 74.2 nautical miles currently, along with 86 nautical miles we're picking up targets.
yeah, so right now we've panned out to 72 nautical miles, and we're picking up a target at 72 nautical miles as well as 80 nautical miles.
And this is with local software, but he's actually by your mouse right now. And our end, we're able to see, trailing and everything like that. The vessel's trails, we're able to, see the AIS transponders live with that current overlay, which is what we're looking to implement on our software side.
So those red targets that we're picking up are right around 74, 86 nautical miles.
74 and 86.
And that's at the outside of their range. They notice that red.
Again, any questions or questionnaire? We want the fill out the questionnaire on our website.
Yeah, absolutely. If anyone has any questions, please feel free to either put them in the chat. We also have a questionnaire. Please fill it out. It'll be great feedback for us. That's on our website.
It's at the bottom of that links tab.
At the bottom of the links tab.
Also wants and needs for data.
Right here, please.
Required.
And evolving wants and needs of their data and features that they'd like to have, and you know, for us to implement further. Probably zoom back in to 10 nautical miles. So we'll go ahead and zoom back in to around 10.
So right now we're honing back into 10 miles. We're going to identify some additional targets.
So if we see right there, that big block is
The southern end.
yep,
So that southern end of that block down there.
that is Second Love.
That is we have the MDAS of Second Love. Their name.
It's current speed of 11 knots, course 191.
We can actually see them on the AS as well. On the marine tracker, it's this guy right here.
And Galeen is to the left of that, to the north.
Yep, and that's them right there.
East at 7.8 nautical
Yep.
miles.
Yep.
And then within that storm, right above this blue area. So we have Miss Blue Heron right here that's just in the pocket of that storm right there.
Yep.
Traveling southbound at 5.48 knots.
That's it. There.
Yep. And that's at 4.59 miles.
I'm not picking up on the AS. We can see Galeen.
Yeah, so currently we were able to pull up these AIS vessels as well, the Galeen and the Love. Those are being displayed.
And locally we have that overlay. It's very clear to discern them.
Hi, Paul. Is this system weatherized? How do you protect the setup from the elements? How big footprint does it take up on a rooftop? So our system is going to incorporate a radome to protect all of the equipment as well as secure weatherproof electrical housings. On the rooftop application, we're going to be using solar, so there is that footprint as well. The actual radar we're using is it's going to be about a 6.5 foot diameter footprint.
And all electronics will be and weatherproofed and everything, and containers and.
It's also secure. It's tamper-proof.
Absolutely.
It's built in for tampering. But we also maintain, house, and there's nothing as far as ownership where they have to worry about the maintenance or any kind of damage or anything like that. That's all. Their subscription encompasses all of that, where it's just solely.
Yeah. So it's again, so as we're offering a subscription basis, that weatherproofing and the all aspects of ownership is going to be put onto us. We're going to own and maintain and operate everything. We're going to ensure that these systems are secured, only offering a data solution. It's going to be tamper-proof. We're going to make sure that only approved personnel can get into it, as well as live monitoring of all of our systems. Has it been tested on a vessel mast? If so, is the reliability in a 4 to 5 foot sea state? So we're looking to test it on a mast. Currently, we've done land-based testing, but we're looking to incorporate testing onto a mast soon.
And this is maritime grade equipment that's already in use globally.
Mhm.
That's been tested on vessels throughout the world.
And absolutely, so, and everything we're using is maritime grade. So it's already been used on vessels. This system it's weatherproof. It's ready to go for open ocean usage.
We can incorporate all those use cases too, whether it be maritime, whether it's on top of condo.
All the technology is currently utilized in government, commercial vessels, and private vessels as well. So
also asked about that 50-foot fishing vessel, and yeah, we could definitely mount on.
It can mount to a sport fish. It can mount to a 25-foot vessel without any issues.
Yeah, absolutely. So for mounting wise, even vessels 25 feet, we're also going to be targeting cargo vessels on top of their pilot houses. That's going to allow us to have a more stable environment, more constant radar data, more level environment.
Not so larger vessels are going to go farther offshore compared to your smaller vessels.
Mhm.
You're able to maintain offshore in abnormal sea state versus a smaller vessel, 30 to 50 feet, where you're going to have issues as far as when they can actually go out there to sea state.
Absolutely, and building on that, so those larger vessels are going to be able to be out farther into the ocean, be out for longer times. In addition to that, ability for more usable radar data.
And that's the reach offshore where those smaller vessels would normally be.
I mean, absolutely, yes. We want. I mean, you can address it, but that's what we want. We absolutely want to have that almost a leap from one radar to another, seeing that track along the entire path. And the more of these systems we have out there, the more we'll be able to cover. And just again, the domain awareness would just be expanded based on how many systems we can put out. I'm going to reiterate
I
that.
would relay the fact that the overall goal is to have this within the entire corner of the U.S. To where it's all integrated, to where we have a true iron wall where they can utilize that.
Yeah, so building on your question, Carol, we looked to incorporate on many vessels to where they could have that effect, where as they went through, we could see them come into multiple vessel ranges, and eventually have them on the coastline where we can incorporate all of that radar data and have an overarching system that's connected, where we'll be able to essentially map the entire coastline and a lot of open ocean with that radar data and be able to track them through each radar array that we have.
Obviously, the more systems that are implemented, the larger the net we have, the basis we have to utilize this. As far as more systems in play, give us more. It's like a cell phone tower, basically. And I would explain it as that. It's much like a cell phone tower. The more towers you have, the more range you have, the more visibility to see the uncharted areas.
This could be client-based, but yes, yeah, absolutely. Have it on a unified system.
Yeah, absolutely. So yeah, we're looking to have it all incorporated into one system, which we're going to be able to offer to multiple agencies, and they can even the ability to work together by utilizing that one data repository. And this also reflects our scalability approach. The more sensor nodes that we have, the more data that's going to be able to be used, and with hopefully the goal of being able to map the coastlines in the United States to solve that intelligence gap.
To cover all the use cases as well.
Yeah, that's a great point. Additionally, to cover all of our use cases for search and rescue applications, drug trafficking, human trafficking as well. Again, to reiterate, so this system that we're developing, it's going to be an array of sensor nodes. There are some solutions that are out, such as using surveillance, but they're too expensive, and they put the burden of ownership onto their beneficiary. Our company is going to own, operate, and maintain all of the units, simply offering a data solution. This source can be shared across agencies and across nations to have one data location for this radar.
It can be tailored based on the operational need of the end user.
Absolutely. So we've been, as we develop our systems, we can also tailor these needs to the need of your organizations. So what we're going to be able to do is we're going to be able to offer your systems with the most, the latest in marine developments as we upgrade our models. We use satellite, so these things can be located anywhere on condo buildings, offshore, on oil rigs, They're self-sufficient, so they can be powered anywhere, and we want them to be able to operate and offer radar subscription services 24/7, 365, from anywhere to anywhere. And once again, on our website that was linked, please fill out the surveys that we've attached. To be amazing feedback from all of you. Also want to take this opportunity again to thank Southcom and the Defense Innovation Unit for their efforts. It's been a huge help. They've been paramount to our development of our technology as well as our business.
This says 600 feet.
We're currently 600.
Yeah, picking up a jet ski at 600 feet
We are picking up jet skis at 600 feet.
from 100 feet above.
Yeah, so additionally, we're picking up smaller vessels such as jet skis right about 100 feet away. Hi, Carol. So how susceptible is it to interference, EMI, etc.? Has that been tested?
Yes. So there's no EMI as far as everything in our system based on the nature of how it's built. It's built much like a regular standard boat. So we're not having to worry about anything as far as anything coming in.
It's all FCC approved. It's commercially available, it's FCC approved.
So there's nothing that can interfere with the system as far as our system, the way it's developed.
Yeah, so Carol, so since we're using components off the shelf, our systems are built for maritime uses such as boats, so there is no interference.
Or worry about it.
Or worried about it, yeah.
During our previous test, we had a lightning storm that was here. We were able to operate within a lightning storm with heavy interference as far as static in the air with zero issues.
Yeah, so we actually completed a previous test, and it was during a lightning storm, and we were able to successfully pick up these vessels as well and adjust our settings to be able to cope with different weather environments and interferences. Absolutely, Carol. Thank you. We'll be reaching out. We are nearing the end of the demo. I want to go ahead and thank everyone again for coming, and please fill out that form for the feedback. Furthermore, thank you again to Southcom and DIU for their involvement. I'm going to put our email one more time into the chat,
It is in the quad charts as well.
as well as it is on the quad charts on our website.
And the site will be here, so they can always look back at it.
Yeah, and that site will always be up. So we can all those resources, all of the quad charts, please,
Share them, whatever.
share them, utilize them. It'll be a great help. Thank you.
And we are open to more questions.
We are going to stick around after 11. If anyone has any questions, please feel free to enter them in the chat or unmute yourself.
I got it. Yeah. No worries.
Do we have a helicopter closing in?
You want to zoom in real quick? We do have a helicopter passing by, and we can pick those up too. For CUAS.
It might be a little high.
It might be a little high. That was him. Yeah, that was him right there. He's going north. Awesome, awesome. All right.
Awesome. Thank you, Sanjay. Thank you, Paul.
Don't hesitate to reach out.
Yeah, absolutely. Please, if anyone has anything, we put that email in there. We'd love to talk more. Good. Awesome. Thank you, everyone, for your time. I think we'll close the meeting. I appreciate you all attending. It's been a huge help. Again, please fill out those forms. It'd be an amazing help to our business and our product development. Thank you again. Have a good one. Awesome.
So they didn't have.
I don't think there's a good view.
Yeah, I think around 12 to 15.
There is. I mean, yeah.